Okay, this is our first podcast, and this is Unit 1, and this is Section 1, first podcast for Honors Chem. So if this is a chemistry class, the best thing to do is start off by talking about what the heck is chemistry. So chemistry, comes with a lot of connotations. When you hear the word chemical, my guess is a lot of you think about this skull and crossbone. They're talking about dangerous stuff. If I tell you there's chemicals in the hallway, you're probably going to think you got to be really careful. And you're probably right. You should assume that unless you know otherwise, that things might have some dangers associated with them. But in fact, chemistry is simply the study of matter, and everything that takes up space and has mass is matter. So you and I are comprised of chemicals, and the desk you're sitting at is comprised of chemicals. So it's not always harmful stuff. So chemistry is simply the study of matter, and matter is anything that takes up space and has mass. So, in other words, everything. Which is why chemistry is often called the central science. It's, of course, the most important science. I'm sure you would all agree. So it involves the study of matter, and that study involves looking at the composition, the properties, and the changes that matter undergoes. Okay, so if we think about matter as anything that takes up space, the composition would refer to what it's made out of. So if I'm talking about water, it's H2O, 2 H's and 1 O. That's its composition. And if I'm talking about properties, I'm talking about something that distinguishes one material from another. So if I'm wanted to describe bananas and how they are different from oranges, I could say a banana is yellow, it's squishy, it turns brown. Okay. So we can have physical properties or chemical properties. So for instance, a physical change would be water changing to ice. In both cases, we have this water molecule both in the water and in the ice, and because the composition doesn't change, this is a physical change. However, if I take water and put it through some chemical process that causes it to become hydrogen peroxide, that would be a chemical change because I'm going from a composition of H2O to a composition of H2O2. So any property that we're talking about that involves some change in composition would be a chemical property. Okay, so we just want to describe what's a physical property versus a chemical property. A physical property is something that gets displayed without changing the composition of the substance. So I can observe the color of something without changing what its chemical composition is, what its formula is. As opposed to a chemical property, that's the ability to change composition or reactivity. So in order to observe it, I've got to change it. So if I'm talking about things here like, is it flammable? Is it reactive? Does it react with acids? Is it combustible? That kind of thing. All right. Let's take a look at these examples and see if we can classify them as physical or chemical. So take a minute and do it, then I'll go over the answers. Okay, welcome back. So I can taste something without changing its chemical composition. So this is going to be physical. I can test whether something is electrically conductive by putting a voltmeter on them, the alligator clips, and putting a voltage meter and see electricity, whether electricity is being generated. So that's also going to be physical because I'm not changing the substance. Flammability would be chemical because in order to burn something to see if it, or to light something to see if it burns, I'm in the process of doing that, changing its composition. If I wanted to know what the texture of a teddy bear is, I can just observe that without changing it. Whether or not something reacts with oxygen or reacts with anything would be a chemical. Any time we're talking about reactivity. Whether or not something is flexible, I'm not changing its chemical composition in order to determine that, so that's going to be flexible. Luster is just another word for gloss. I can tell if something's glossy just by looking at it without changing its composition. Whether something floats or sinks will depend on whether or not it is more or less dense than the substance it's going to float or sink in. So I don't change its density by observing that, so that's going to be a physical change. Odor, if I have a skunk, that's going to be a physical property because it's something that does not change chemically just by the nature of whiffing it. Whether or not something has a reaction to heat or whether something is explosive is going to be a chemical change. Again, we're talking about a reaction. The color of something, again, I can observe it without changing it. That's going to be physical. Tarnishing, which is actually a reaction with silver, because I'm talking about a reaction, it's chemical. So if one of your parents has some old silverware and it has tarnished, that actually has undergone a chemical reaction. So there's a substance on the surface that was not there before that changed some of that iron in it to a different substance. So that would be chemical. Okay, so let's take a look at doing a couple of examples with physical and chemical properties. So aluminum, let's say a property of that would be that it's silver. I could also say it's malleable. It was able to be formed into a pan. I didn't have to change its chemical composition to do that. And let's say a chemical property of aluminum is it reacts with acid. Anytime I'm talking about reacting with anything, that's a chemical property. Ethanol, this is the substance that could be used to power your car, and it is a transparent liquid. That would be a physical description. A chemical description is it's combustible, and it's that combustion of the ethanol that fuels your car, generates lots of heat. We can also describe properties as being intensive or extensive. Extensive, let's start with that. That's a property that depends on how much you have. It depends on the amount. So things like volume or mass would be extensive. It changes with how much I have. Intensive is a basic property of the substance. So for instance, things like color. Doesn't matter how much I have of something, it's going to be the same color. Odor. Density. If I have a little tiny bead of aluminum or a big pan of aluminum, the density of that aluminum is going to be the same regardless of how much of it I have. Okay, so let's talk about physical and chemical change. So in a physical change, I have a change in appearance but not a change in composition. Okay, as opposed to, so here I have water, it's boiling. This is a bunch of water molecules, H2O. It boils. When it boils, the gas molecules up here are also composed of H2O. And because the molecule is the same, the composition is the same, this is a physical change, even though it looks different, as opposed to a chemical change, which involves change in composition. So if I burn this log, the process of burning it causes it to become a new substance with a different composition than it started with. So this is a chemical change. Okay, so let's take a look at down at the molecular level, what's going on physical and chemical. Let's see if we can figure out what's going on here. So we have some very cold liquid nitrogen, and it's cooled even further until it freezes. Okay, so nitrogen is what we call a diatomic molecule. It exists as two nitrogens connected to each other as a molecule. we have several diatomic molecules. Oxygen is another one. It exists as O2. Okay. Nitrogen is normally a gas with the molecules pretty far spread apart. Here it's a liquid. We have the nitrogen molecules relatively close to each other. When it freezes here, we have the nitrogen becomes nice and neatly arranged and closer together. Here it becomes a solid. And because in both cases we have the chemical composition of N2, this would be a physical change. Okay, so if we take magnesium and we heat it in oxygen, what happens is here I have let's say a strip of magnesium. It's a bunch of magnesium atoms side by side. I have oxygen in the air. Remember we said oxygen is also diatomic. It's got two atoms of oxygen together. And after that heating occurs, I now don't have magnesium. I have this magnesium with a charge on it, which is different. And I no longer have the O2. I rather have these individual oxygens also with a charge on it. And I have one substance as opposed to here I had two substances. So I have changed composition here. So this is going to be chemical. Alright, here I have sodium chloride is added to a beaker of water and left to dissolve. Okay, so actually this is one that's often debated whether it's physical or chemical, but the way it's presented here I have sodium chloride, which is in this lattice work where I have sodium pluses and chloride minuses alternating. That's what a salt crystal, if you had table salt, would look like, the alternating positives and negatives. And then I have these water molecules, if I put it in water, that surround it. And what the water molecules do is pull these positive sodiums and negative chlorines apart. So if I look at what I have afterwards, I still have water, right? I still have water, that hasn't changed. And I still have the Na plus and the Cl minus. And because of that, most people would say this is a physical change. But others would say, you know, here I have NaCl, and here I have Na plus and Cl minus, which are separated, which makes it different, which makes it chemical. So sometimes it's not always perfectly clear. Okay, so we want to take a look at these and decide whether or not they're chemical or physical. So I'd like you to try to answer whether A go into B and then A go into C are physical or chemical. Okay, so let's take a look. If I look at A, let's write a formula for this. I'm going to call it red to blue. That's what I have here. I can write that as a chemical composition. When I get over here, I have two different substances. First of all, I have an R2 and I have an RB. Clearly something has changed, so that is going to be a chemical change. If I look over here, if you notice, each little unit here is also an R2B. I just have them lined up together. And because it's the same composition, this would be a physical change. So how about this? Here I have an RB and an R, right? And it becomes an R2 plus a blue. Clearly, change in composition. This is a chemical change. Okay, so let's talk about states of matter a little bit, and we're going to talk more about this in class. But if you notice, what you have here is you have, in a solid, you have the particles very close, generally very nice, neatly arranged in rows and columns. Nice geometric pattern. Liquid, particles still close together, but a little bit less ordered, right? And then when I get to a gas, particles are much further apart. So if we look back, if we looked at the previous slide, what we see is that we have the same stuff when it's a solid, a liquid, and a gas. So states of matter changes are always physical changes, and that's a common thing students will get wrong. They'll consider that to be a chemical change, but it's just a physical change. Okay, we're going to stop right there.